All right, so we're going to enter the refrigeration plant now. As you can see here, we've got an emergency ammonia mask in this case. All staff do have fitted respirator protection themselves, but when you can't get to it in time or you need to, it's right here. So we've got these different lights here that will give us indications of any upset conditions. So for our low level alarm from 25 parts per million to 100 parts per million, we would see this amber light going. If it hits the 100 parts per million or higher, the blue light will go off and the plant will de-energize. And then the red light is just a nice one for us. That's giving us, for our chlorine gas for the pool disinfection, that just gives us a heads up if we were on this side of the building and there was something wrong in the pool, that we'd see that red light strobing.
Right, and the amber light and the blue light parts per million is for ammonia.
Correct. Yeah.
That is, yeah. While we're out here, could you tell me why we use ammonia in refrigeration?
Well, ammonia is probably one of the best heat transfer refrigerants out there. It's also actually a natural refrigerant, so it's not like Freon, where Freons, even their newer blends, they're now calling them like greenhouse gas reduced freons, but they still have ozone depleting. Ammonia is a natural element and it doesn't have any harm to the ozone layer. You know, it can have some environmental problems in high levels, but as it's a natural element, so you know it's one of the more commonly used ones in our industry, although that's changing now.
Right, and then I will talk to the class about the Fernie accident.
Yeah.
But the Fernie accident, in their arena, they were using ammonia as well, correct?
Correct. Yeah.
Yeah.
And you know, it was a series of tragic events that had they done different things in maintenance wise, that incident probably would not have happened and 3 people wouldn't be dead right now. So.
Right, and I'm sure that WorkSafe has come pretty strict down on all of the arenas since that accident, and I know you had mentioned some changes in the Nelson arena. Were there any changes that you can think of, or
well, when Fernie happened, I was still at the Nelson arena, and you know, we had some incidences previous to Fernie, and so our plant was well above the curve. We were up to snuff. So for our operation in Nelson at the time, we came through all the technical safety and WorkSafe inspections with flying colors. We had no deficiencies, we had no non-compliances. Other places not so bad, didn't do so well. Some arenas did have to shut down because they just were so far gone that they had to rebuild and replace a lot of infrastructure. Castlegar, you know, we're up to snuff here now. They had a couple minor things to deal with, but nothing that was a showstopper that stopped their operations.
Right. Okay, gotcha. So I was wrong there. You were above in Nelson. I was getting my facts wrong.
Yeah.
Right.
Yeah. No, we were way ahead of the curve. I think probably in the whole province, we were one of a handful of arenas throughout all of BC that came out of it completely unscathed and ahead of the curve.
Right. Nice. Well, thank you. So when we walk in, all of a sudden I see some blue little...
Yep. So this is what you would call a vestibule. So we have a double door system like you should in a Class T machine room, they call it. So when an operator comes into this room, they turn on the light switch out here, and then all these here are the staff, all the different staff's breathing apparatuses, respirators. Inside the room we have an emergency eye wash and shower, and we also have on the left hand side there our ammonia remote detector that would tell us how many parts per million in the room. You'll see it if you look at it for a minute. It'll have an alarm 1 and alarm 2, P1, P2. So P1 is the sensor in the plant, and P2 is a sensor in the relief stack. And that was new and came out of the Fernie incident. So all plants that didn't have relief stack monitors now are supposed to have them.
Oh, that's interesting. Okay. And do you have to wear a detector when you walk in?
We don't have to yet. That may come, but we always have to take a bite block respirator in with us.
Okay.
Or you can take your half mask or full mask. You'll also have in here, we have a main, so the emergency exhaust fan, this would be to turn it on to 100%. And then of course in an upset condition that our operators can't deal with because we can't technically fix anything by our RO status. We can just maintain and we can tighten a bolt or isolate. And if we can't, then as we leave this room, we hit the emergency exit and shut the entire plant down.
Oh, okay.
So.
Sorry, was that new since?
No.
That one's been there.
All of them should have it, and
Right.
some places again deficient or not. Castlegar had that in already.
Right.
Another thing you'll find in your vestibules, you should have kind of drawings of your plant. It'll give a brief overview of your valves, so they would call that a valve ID or a valve tag chart.
Oh, my students will be so excited to see a P&ID. Look at
Yes.
that. They love the fact that I make them draw one at the end of the program. Awesome.
And then this here is great. The former chief engineer had a nice write-up here, shows all our different pressure release in our operations, and it's nice, you know, every 5 years when you have to replace them. We can just take a picture of that, send it to our contractor, and in our off-season they can come in and replace them all for us.
Oh, and all of your parts and everything. That's really nice to have.
Yeah.
Perfect.
So I have the plant turned off when it wants to be on, so when we go in there you're going to hear a beep every once in a while. But
All right.
at least it's better than the compressors running.
Thank you.
Okay, so we're in the plant room now. So this here is a secondary heat recovery system for this facility. So you'll have high pressure ammonia gas post compressor, so in the discharge, will come in through this heat exchanger and supply heat into these, transferred into these glycol lines, and that's plumbed off over to a heat pump in our pool, which will supplement building and pool heating. Of course, this piece of equipment that's making noise right now is our normal 24/7 exhaust fan. We have to, by code, have a certain amount of air changeovers in here. And then on the other side, that emergency exhaust switch that I showed you, the big one up top there, if we have an emergent condition, then we hit the switch and that would give us a very large air changeover going through here. When we were outside looking at the condenser tower, we talked about the water reservoir. So this is our cooling tower, if you want to call it. So this holds our water that gets circulated through the condenser tower. We do have a float in there because with that evaporation of the heat when we release it, you do lose water. So we have it set up so it keeps a normal level. This is the pump right here for the water side of our evaporative condenser. And it just runs, I think it's a 3 horsepower pump that just continually feeds water up to the condenser when the plant is running.
Do you have automatic valves that fill this tank up when you start to get low?
Yeah, it's got, you know, this is a less technical but works very well, just like a toilet float in there basically. And it's been, you know, eyeballed over time to say, okay, when it gets to here, it'll open up a